Hi guys. I want to go ahead and get started on the next little unit, which is all about rational expressions. So I'll probably break this into several parts, at least three or four, and we'll kind of work our way up through baby steps through these rational expressions. So first of all, the first thing that I want you to remember, we've talked about the word rational before. And when you think of the word rational, I want you to think of a fraction. So we're going to be dealing basically with fractional expressions. And when we think of the word expression, it is not an equation. So it's not something that we're solving yet. But an expression has variables in it. And we're going to be simplifying as much as we can. So we're going to work our way through simplifying, multiplying and dividing, adding and subtracting, and then finally the fourth little unit will be solving rational equations. So we're going to start out with this first unit, and all I'm going to ask you to do for now is to simplify. Now, what I want to do is kind of compare this to something you're familiar with. So if I ask you to simplify the fraction 3/6, most of you would probably already know in your head that that's 1/2. So here's the reason why it's 1/2. And then we're going to use this same logic with some more complicated expressions. So what we can do is we can think of factoring this. So I will tell you that factoring is going to be a huge skill that you need for this whole unit. Now, when you factor something like this, I just mean split it into factors. So 3 is 1 times 3. 6 can be factored into 2 times 3. So the whole premise here is you are factoring things, and then you are looking for what you have in common from the top and the bottom. So we have 1 times 3 and 2 times 3. So that means the numerator and denominator both have a 3 in common, which means we can get rid of those, because if you think of this, this is like the fraction 3/3. 3 divided by 3 is equal to 1. And what does a 1 do for us here when we're multiplying and dividing? Nothing. So essentially, the way that we can kind of shorten that to think of it is when you have the exact same thing on the top as you do on the bottom, as long as everything's being multiplied and divided, you can just get rid of it. So what that means is we just have 1/2 left. Now, a second example that looks like this, let's say that we have 8/24. Now, when you factor these, especially just these basic numeric ones, you don't necessarily have to do a full factorization. For example, 8 factors down into 2 times 2 times 2. And then 24, factors a little bit more. But what I know is 8 and 24 have a common factor. So what I'm going to do is leave the top one as 1 and 8, and I know on the bottom I can factor that into 3 and 8. So the whole idea is we're trying to factor so that we end up with things alike on the top and bottom, because the whole goal is once you have things alike, then you can cross them out, and you're left with a more simplified expression. Okay? So now let's start making these a little bit more complicated. So let's say that we have 12x to the third y and 6x y to the fourth. Now, some of you will get the hang of this a little bit quicker than others. Some of you may want to write out a little bit more than others, and that's fine. Just kind of practice it and see what works best for you. So I'm starting out with my numbers, and I already know that they have 6 in common. So what I'm going to do is make this 2 times 6 and this 1 times 6. So that's my first thing that I'm going to start out with. Now, with my variables, I have x to the third, which means I have 3 x's, and then I have a y. Then down here, I have a single x, and then I have 4 y's. So what we can do now, let me see if I can find another color pen. Of course I can't. This Sharpie will work. So my 6's go away. Then I can get rid of one x on the top and bottom. So you notice I have extra x's left up here, but I don't have anything to pair them with. So they just stay as is. I can get rid of one y from the top and bottom. Again, I've paired up everything that I could possibly pair up. So now what I'm looking for is what's left. So I have a 2, and then because I have two x's, that's going to be x squared. I have a 1 down here, which you can write the 1 on the bottom if you want, but you don't have to. Up here, if you have a 1 on the top, you have to put that if that's the only thing you have left. So just for consistency, I'll call it 1y cubed. Okay, so we're simplifying. We're getting rid of things that are alike on the top and bottom so that we can cancel things out. So for this next one, this would be a good time for you to pause the video and give it a try yourself and see what you can come up with. So we're going to have 18x squared y to the third and 24x y to the fifth. So like I said, if you feel like you've got it, go ahead and pause the video and try this one. And then I'll continue to go through it. And so when you unpause, you can see the answer. So when I'm looking at these, I'm trying to think about the biggest number that they have in common, the greatest common factor between these two numbers. So 18 and 24, the biggest common factor that I can think of is 6. So 18 would be 3 times 6, 24 would be 4 times 6. Then I'm going to write out my variables. Okay, so once I get everything written out, then I can go through and I can pair things up top and bottom to get rid of any of my pairs. So now I have left on the top just 3x, and on the bottom I have 4y squared. Now, if you don't want to take the time to write out all your variables, one thing that maybe you're noticing, I had 3 on the top, 1 on the bottom. The maximum I can get rid of is 1, so there are none left on the bottom and 2 left on the top. With my y's, I had 1 on top, 4 on bottom. The most I can get rid of is 1. That makes this one go away, and I only have 3 on the bottom. So you kind of get the idea there. 2 and 1, I can get rid of 1. So this one's gone, 1 left on the top. 3 and 5, the most I can get rid of is 3. These are all gone. If I get rid of 3 down here, I have 2 left. So you don't have to write those all out if you don't want. It's just an option. Some of you prefer to be a little more visual than others. Okay, so now what we're going to go to is some slightly more complicated ones. And these are going to require your factoring skills, okay? So for this example, you are going to have to be able to factor out a GCF. So I'm looking at one part at a time. So just looking at the top, 2x plus 4, GCF, that's the biggest number I can divide by, and potentially do I have any variables in common? And I don't. So what I notice is among the top, I can divide both of these by 2. So that would leave me with 2 times x plus 2. And it's also personal preference too, if you want to write them out to the side like this, or a lot of times what I'll do is I'll factor something and I'll just write it above or below it. But that's kind of your personal preference. So 2x plus 4 turned into 2 times x plus 2. Down on the bottom, my GCF would be 3. And so if I took out a 3, I would be left with x plus 2. So now what you'll notice, and maybe it does help to write it out like this, is I have this expression 2 times x plus 2 over 3 times x plus 2. Since I have multiplication going on in the top and the bottom, what I can do is, because there is an x plus 2 in both the top and the bottom, that can go away. Those are common factors that I have. So x plus 2 divided by x plus 2 is 1, so I don't really need it. So what we say is this is just simplifies down to 2/3. Okay, now there's some things that I'll get into in the next video that talks about values where your function, the domain doesn't exist. And technically, we would have to say 2/3 as long as x is not equal to -2. But I'll get into that in the next video. For now, I just want you to practice with the factoring and the simplifying. So here's another one. Again, go ahead and pause and give this one a try. So you are just factoring out a GCF, and then you're going to see if you can simplify from there. So if you tried this one on your own, GCF on the top, I'm looking at 9 and 3. So the biggest thing that I can divide by is 3. So if I divide each of these by 3, I have 3x plus 1. Then what I want to do is look at the bottom, 12 and 4. The biggest thing I can divide by is 4. So if I divide each of these by 4, I have 3x and I have 1. So again, what you notice, same thing on the top and bottom. Those cancel out. So this expression simplified down to 3/4. Let's see. So now how about x squared plus 2x plus 1 over x squared minus 1. So now we're getting into a little bit more complicated factoring. We have to remember how to factor quadratics. That's our expressions with x squared. So on the top, when you're looking at just the top, remember we're looking for something that will multiply to give us this number and add or subtract to give us this middle number. So I know to get x squared, it has to be x and x. Multiplies to give me 1, adds to give me 2. That has to be 1 and 1. Okay, so now switching to the bottom, x squared minus 1. This is one of my special cases. This is a difference of 2 squares. Some of you like to think of it like this. The middle term is missing. So what multiplies to give us -1 that will add or subtract to give us 0? So we know to do our x and x. So to multiply to get -1, the only thing that we could do is a +1 and a -1. So now what you'll notice, you have things that match on the top and bottom. Now, you cannot get rid of both of these on the top for the same reason that your variables up here. I had 2 x's on the top, 1 on the bottom. I could only pair up 1 to 1. So I can't get rid of this other x plus 1 unless it has an exact match to go with it. So this ends up simplifying down to x plus 1 over x minus 1. So one more here, and again, I encourage you to pause the video and give this a try on your own. So we have x squared plus 6x plus 5 over x squared minus x minus 2. So if you tried this one on your own, hopefully you were able to factor. So x and x, multiply to give you 5, add or subtract to give you 6 is going to be 5 and 1. On the bottom, multiply to give you -2, add or subtract to give you -1 is going to be -2 and +1. Then it becomes pretty clear. These cancel out, so I am left with x plus 5 and x minus 2. So that's kind of an introduction to simplifying rational expressions. And like I said, in the videos to come, we're going to do more simplifying practice. I'm going to talk about undefined values. Then we will multiply, divide, add, subtract, and solve equations.